Hi everyone, my name is Srujan and today I'm going to be discussing this problem titled Array Reordering. So let's quickly go through the problem and what it says. So we're given an array consisting of n integers and we have two indices I and j. We call these indices good if I and j both lie between 1 and n and I is less than j, and the second condition being the GCD of a of I and 2 times of a of j is greater than 1. Note the special thing that we're having in the GCD, which is GCD of a of I, comma 2 times of a of j is greater than 1. So we're supposed to find the maximum number of these good index pairs if we can go ahead and arrange or reorder this array in any way that's suitable to us. So right out of the bat, we can notice that the time limit per test given to us is 2 seconds, which allows us to follow a brute force approach to this question without having to think too much about the efficiency and trying to implement a data structure right out of the bat. So this is also confirmed by the problem tags, which says brute force, greedy, and this is a 900 rated problem. So let's look at this condition, which is GCD of a of I times a of I, comma 2 times a of j. And why exactly that is special? Let's look at this in terms of parity, whether a number is even or odd. So let's switch over to here. So if a of I and 2 times a of j is the condition, and let's assume a of I to be even. Regardless of a of j being even or odd, we can safely say that the GCD of these two numbers, the minimum most value of the GCD of these two numbers will always be 2. Why? Let's look at this with the help of 2, 3 examples, right? So we're assuming a of I to be even. So let's say it's 2 and a of j is 5. So 2 times 5 is 10 and the GCD of this is 2. All right, let's take another example. Let's say 6 and a of I is 6. And let's say this time let's go with a of j being even 2. So let's say 12. 12 times 2 is 12 times 2 is 24. So you'll have 6 and 24. Right. So the greatest common divisor here is 6, which essentially satisfies our condition, which wants the greatest common divisor to be greater than 1. So the condition we should go ahead and exploit, and the condition which is the most optimal for us is to have a of I being an even number, and we don't really care if a of j is even or odd. So based on this, we can go ahead and rearrange the array uh, to have the even numbers on one end and followed by the odd numbers to get this pattern of you know even followed by any number multiplied by 2, which gets us another even number whose GCD's minimum most value is 2. Maximum value can be anything, depends on the numbers obtained, but the minimum most value that could come is 2, which again satisfies the condition we have, which wants it to be greater than 1. So how do we go ahead and implement this, right? Let's quickly look at the code as well. So we'll be taking in the number of elements for each array, and we've created a vector for the main array, and I've also created two other arrays known as odd and even. So we'll take the input for the main array, and then what we'll do is we'll out of these two arrays, odd and even, we'll go ahead and based on the parity, which is even or odd. So this condition checks for even or odd. A of I mod 2 is equal to 0. As I'm sure you already know, mod 2 gives us the remainder by dividing by 2. So you either get 0 or 1. If it's an even number, you get 0 because there's no reminder when you divide by an even number. You get an even number. So I'm essentially putting this number inside of even. I'm pushing this inside of even. Else, if it's an odd number, push it inside this array called odd. Then we're clearing this array, original array that we've got, and using some clever existing uh, metrics for vector manipulation, we've gone ahead and, essentially added this back into the array in the form such that there's first even numbers and then followed by odd numbers. So if we had to look what this, if we had to see what this looks like, I'll just quickly go ahead and print this. Didn't forgot the input. So let's take this input here. Okay, there must be some problem that has happened. Let's try this again. Yep, there we go. Right, we forgot the space and the next line. So our initial array was 3653, but after rearranging it in terms of even followed by odd numbers, we have 6353. For 1 and 7, there's no even numbers, so it's the same 1 and 7. For 14241, we have 42411. Did, there could be an additional step of sorting it, but it makes no difference to us because in the end we're still finding the GCD, and it doesn't really matter for us to find this GCD. Sorting doesn't really matter. So if I had to go ahead and recomment this, and if I had to go ahead and remove this, after that, after making this array into how we want it, we're gone ahead and established and initialized this variable called count. And for the loop, we're having two variables, which is I and j. So we're having I starting from 0 and j starting from one position greater than I, such that if we have so I'll be tracing this with an example, with tracing this particular example in just a few seconds. But then, if you had to understand it, so we're essentially checking the condition which is given to us in the problem, which was GCD of a of I, comma 2 of a of j is greater than 1. Where just winging it, we're brute forcing it, which there's no additional math involved. We're just gone ahead and rearrange this array, and we're checking the same condition as is. So let's take the example and track this question, right? So first we have 14241, which is transforms into 42411. So if I had to clear all this, yeah, 42411. So our I variable is here and our j variable starts from here. So our j checks the GCD of these two first. So we found 4 and 2 times 2, which is 4. So we'll be checking the GCD of 4 and 4 for the first case. GCD of this is 4, which is greater than 1. So the count value will be plus 1. So I'll be using a tally marker because it will be easier for me to track on this Excali draw thing. So let's say I keep count as C and I keep it like this. So we'll have 4 comma 4. And then we'll go over to here 4 and 4. So this will be multiplied by 2. You'll have 4 times 4 and 8. 4 and 8 GCD will be 4. So 4, 8. Yeah, forgive my handwriting. GCD will be 4. So the tally marker will be increased by 1, which means count has been increased by 1 more. So 4 and then 1 times 1 times 2. So you'll have 4 comma 2. whose GCD is 2. So the tally marker increases again. Then you'll have 4 comma 1 again, which means 4 comma 2, which means the GCD is 2, which means the tally marker goes up again. Then we'll have the I variable updating because we've reached the end of the array, right? The condition goes only till n for both I and j. So we'll have from here, and we'll have j value starting again from here. So 2 and 4, so this will be 2 and 8. Let's quickly write this down. 2 and 8, whose GCD value is 2. So the tally marker goes up and we have 5 now. Then 2 and 1, which means it'll be 2 and 2, whose GCD again is 2. Tally marker is up by 1 more, and we'll have 2 and 2 again, which is tally marker up by 1. We'll have 7. So the I variable increases again. We'll be over here. Let's see what we get. So we'll essentially be doing it the number of times or the number of even numbers we have that will be giving us the answer. So that's basically till where we're going ahead and doing this. Because once we hit a of I or this I variable being odd, there will never be a case where the GCD is greater than 1. Because for an odd number and an even number, unless that second number is a multiple of the first number, will always be 1, right? So, but then there's that option of multiple. So we'll still need that loop running. We can't really end it at the number of events and just call it a day. So for this case, we'll have 4 and 4, 2 times 1, which is 2. So you'll have 4 and 2, which is GCD of this is 2. So you'll have 5 and 8, and this will repeat again. So you'll have. Hi again. My laptop crashed, so here's the continuation of the explanation. So after we go for I value as 1, we see that 1 and 1 is not really possible because the GCD of 1 and 1 is 1, which does not satisfy our criteria, which is greater than 1. And for 4, we have 4 and 1, which we get as 4 and 2, whose GCD is 2, and 4 and 1 again, which is 2, which satisfies the condition again. So we have the value of C, which we get as 5 plus 4, 9, which is our correct answer. So let's quickly try this. Uh, let's quickly try this and see if we get the right answer with the code we've implemented. So yeah, we get 409, and this is a correct answer, got accepted. With that, that concludes the end of this problems explanation. Do let me know if you have any questions, if you have any sort of things that went unresolved, or if you have some feedback for me on how I could have explained this better, uh, please do let me know. Thank you and see you next time. See you tomorrow.